Okay, let's go again. This one says cosine squared over 1 minus sine theta. We want to try and make this big old fraction into one thing, maybe just one term, like tangent or something, just one thing. Okay, so you might be alerted by this number 1 and this sign. Well, remember, the only time that a 1 and a sign should alert you is if there's a squared on that sign, because then it would alert you to the Pythagorean. But we don't have a squared on that sign. Okay, let's see here. Everything's already on sines and cosines, so it seems like we can't do anything, but we can. Let's plug something in for this cosine squared. So let's look for something on this paper that I could plug in. I know cosine is 1 over secant, but what the? If I try replacing cosine squared theta with a 1 over secant, it's going to have fraction on fraction. Scary. Don't do it. Here's a cosine, but it involves sine and tangent. What the heck? Hey, here's a cosine squared. Let's use this Pythagorean identity and just see what happens. If I'm wrong, we can fix ourselves, but I'm right. Okay, so we're going to use this Pythagorean identity that says sine squared theta plus cosine squared theta equals 1. And again, I want to take this cosine squared theta and replace it with whatever it is equal to. So let's figure out what it's equal to. Let's find just cosine squared theta. What is cosine squared theta equal to? Well, let's see. If I want to get rid of this sine squared, I subtract it over here. I subtract it over here. Okay, so cosine squared is now just equal to 1 minus sine squared. And that kind of seems like we're just going to be making the problem more difficult, but trust me. So we just said that cosine squared is equal to 1 minus sine squared. So let me write that down. Okay, and we're all over 1 minus sine. I know you really want to cancel out the ones, but you're wrong. You cannot cancel the signs. Remember, fraction rules say the only time you can cancel is when you're multiplying, or the only time you can divide out the common factor is when you're multiplying. So I cannot cancel those. But maybe we can do some algebra. Algebra. Let's see here. I have it written down somewhere. That top, 1 minus sine squared theta. Where the heck is that piece of paper? Hey, man. Oh. Hey, you remember that thing called factoring? If I had x squared minus 9 and I factored that, what would it be? X plus 3x minus 3. Why? It's true. If I had x squared minus y squared, what would that be? X plus y, x minus y. These are differences of squares. It's the same thing, but with a plus and a minus. What about sine squared minus cosine squared? It'd be sine theta plus cosine theta times the same thing with a minus. Woohoo! What about 1 minus sine squared? Well, let's see here. The way I got these 3's up here is because I square rooted that 9. Same thing here. The square root of 1 is 1. So I'm going to say 1 plus tangent? No, sine. Sine theta times 1 minus sine theta. Hot dog, we just factored it using a difference of squares. Let's use what I just wrote down here. So we're going to take this sucker and we're going to factor using algebra. Oh, my dog. And if we factor that, we got 1 plus sine, 1 minus sine. And the bottom, I'm just gonna keep it the same. And remember, the whole point is to cancel things. Well, let's see here. These tops are multiplying because of the parentheses, multiplying. So now we can cancel this 1 minus sign on the bottom with this 1 minus sign on the top. And you get 1 plus sine theta. And then the last thing to do is to try and check and see if we can somehow make these two terms become one. And if it was a squared, then we could use a Pythagorean identity if this sign was squared, but it's not. If this was 1 over sine, we could totally change it to cosecant and be done, but it's not. It's got a plus sign. So there's nothing, we could change sine to 1 over cosecant, but then I'd have a whole number plus an even more complicated, okay, yeah, so this isn't it. So 1 plus sine is the answer. What? So not all of our answers are just gonna be one chunk or one term. Some of them are gonna be 2 terms, 3 terms. Okay, let's go. Let's do something called verifying. This is like number 5 on the homework. Verify means prove, show. So on your homework, you're not just gonna write down an answer. You have to write down each step of your work. Ay, Dios míos. Okay, calm down. So we're gonna verify. We are going to show that this left side is equal to this right side. And in your homework, it usually has you work the left side to get the answer of the right side. So this is kind of like we're simplifying, but they gave us the answer. It's sine. The whole point of verifying is to prove to your math teacher that you know what you're doing instead of just photo mathing it. Okay, so we're gonna start trying to simplify, trying to plug things in, and we are just going to work on the left side. Awkward. So first, let's change everything to sines and cosines. Cosine is already there. Tangent, let's see what that's equal to. Here's an identity, tan equals 1 over cot. I just told you to change it to sines and cosines. Here's a quotient, tan equals sine over cosine. That's what I told you to do. So we're gonna use a quotient there. Sine theta over cosine theta. And if you haven't figured it out yet, in your homework, you need to write the letter X instead of theta. I just like using theta because the X makes me feel like it's an English paper, like sine X, cosine, what the heck. Okay, anyway, and then there's a dot and there's cosine theta. So the first thing we did, the very first thing we did was express in terms of sines and cosines. So in your homework, this is where you're gonna type this mess and then probably pick the answer choice that says express sines and cosines. Okay, then what happens? Something from before. The cosines cancel. And we just get sine. And hot, look at that. That's what our answer was supposed to be. Oh, we just did this right. Yeah, that's cool. And hey, this scratching out thing I just did, it's called canceling, but remember the fancy way the homework writes it is separate the quotient into 2 terms. So that's what you're gonna pick. You're gonna pick separate, answer, crap, separate, wait, no, I don't know what I'm saying. What the heck? No, we just divided out the common factor. I'm a fool. So you're gonna write divide out the common factor. So in your homework, you're going to have to type this over here. You're probably going to have to type this right here, and then you're going to have to pick these answer choices. Okay, let's maybe do one more, and then I'll roll over the tape. Okay, number 6, automatically. Even before you do sines and cosines, I notice this negative. What the fluff? This negative is jank. It's in the parentheses. Let's see if maybe I can replace this whole nasty, janky thing with something where the negative is not in the parentheses. Okay, earlier we talked about even-odd identities where tangent of a negative theta is equal to negative tan. And I said its reciprocal, cotan, is the same thing. So that means cotangent of a negative is equal to negative cotangent. So this cotangent of a negative is equal to negative cotangent theta. And I'm going to just bring down that sine theta. And what side are we working on? Oh, we're working on the left. Remember, we're working on the left, and our answer is on the right. So your homework is going to expect you to type this in. And what the heck did we just do? We just applied something, even-odd identity. We just did that. We just did an even-odd identity. So your homework, you type in this negative cot sine theta, and you pick the answer choice that says you just did the even-odd. Whenever you take a test on paper, you're not going to write down anything on this right-hand side. I'm just doing it because of your homework. Okay, now let's write things in terms of sine and cosine. So this cotangent, let's see. Here's cotangent. It's equal to 1 over tan, but that's not what I just told you to do. I just told you to write it in sine and cosine. Hey, here's cotangent, and it's equal to cosine over sine. So let's do that. We're going to use a ratio identity or quotient identity and express in terms of sines and cosines. As in, cotangent is cosine theta over sine theta. There's still multiply by sine theta, and there's a big fat negative on front. Okay, now we're going to do what we did on the last example, where you cancel. And when you cancel, you get negative cosine theta. How do I know whether that's right? What? The answer's right here. Hello, moron. So we did it correctly. And that thing I just did with canceling, remember, that's called divide out the common factor.